Well, good day, everybody. This is Chris with the Ancient Scholar. What I'd like to do today is I'd like to do a quick video on making the transition from undergraduate studies to either post baccalaureate or graduate level studies. So, in the last year, of course, I've completed a bachelor's of science in nursing. I also have several associate, or I have a couple of associate degrees in addition to that, all of which are applied science degrees. And so what I've done in the last year is I've actually made the transition into working on graduate level work in the area of pharmaceutical sciences, concentrating on clinical toxicology. So what I'd like to do is just kind of take you through one of the projects that I've had to work on for one of the classes I'm doing, and just kind of show you the difference between the types of work that I do, and kind of compare and contrast that a little bit to the baccalaureate studies. So one of the major transitions that you will end up going through is you will have a narrower focus for the most part when looking at graduate level studies. So when you do your bachelor's degree, even if you did something that's more vocationally focused, like I did, obviously nursing has a strong vocational component to it. There's some sort of task that you do. Even though typically a bachelor's degree is going to be fairly broad in its scope, and that is to say that a lot of bachelor's degrees, regardless of the area that you tend to focus on, if it's a science degree, are you looking at physics or chemistry or biology, perhaps engineering, or if it's an arts degree, are you looking at literature, history, communications, etc. Um, in spite of having certain areas that you look at specializing in, there tends to be kind of a common core of subjects that you will end up doing. You'll study a little bit of history, fine arts, humanities, mathematics, common core classes, and a bachelor's degree tends to be fairly broad in that sense, that you, in addition to whatever specialty classes you may take or concentration classes you may take, there's going to be an underlying theme of a broad based level of education. You're going to have a broad focus of classes that you'll have to take in addition to whatever specialty classes you take. Now, when you start looking at graduate level classes, you're going to narrow your focus considerably. For example, the classes that I'm working on now, I don't have any humanities or fine arts whatsoever in these classes that I'm working on toward well, initially it'll be a post-bachelor certification halfway through, and then follow up with a master's of science. But what I'm doing is I'm doing a pharmaceutical science degree that has a concentration in clinical toxicology. So I've really narrowed my scope down considerably, even from just a run-of-the-mill Bachelor of Nursing, if you will. And now I'm really focusing on pharmacology, and even more precisely, I'm focusing on toxicology. So this is just an example of one of the papers that I've written for that class. This is a paper that goes by the name of Toxicokinetics, a focus on intraoral absorption of xenobiotics across intestinal membranes. Xenobiotic is just kind of a buzzword for a foreign substance it could be anything as simple as just taking aspirin or Tylenol. It's just a substance that isn't normally produced in the body. It's kind of one of those buzzwords, if you will, that you'll see used in certain circles in toxicology. So it starts off more or less like a run-of-the-mill APA paper. It has the running head, has a title, my name, university that I'm going to, etc. Starts off with an abstract. It says it'll discuss toxicokinetics, absorption of xenobiotics, pertains to intestinal membranes. So I'm talking about toxins and how they are absorbed across membranes in the alimentary canal or the gastrointestinal tract. I'll talk about barriers of absorption, membrane permeability of certain medications, response to pH changes. We'll have a focused discussion on aspirin or acetylsalicylic acid. And then we'll talk a little bit about something known as the P-glycoprotein system as they apply to xenobiotic absorption or inhibition of absorption in intestinal tissues. So you can see it starts off, but if you look at kind of the focus of the paper and the scope of the paper is a bit narrower than you may be used to. Even in your pharmacology classes, I do start off fairly broad, and I do an overview of pharmacokinetics. And we actually in toxicology have something called toxicokinetics, which is just simply pharmacokinetics. We use exactly the same concepts, exactly the same equations are used at the fundamental level. Okay, so when you talk about absorption, distribution, metabolism, or biotransformation and excretion, these are things that are at the basic level should be very well known by most providers, but especially people like nurses. So I just kind of describe pharmacokinetics because that's really the primary way that we describe toxicokinetics. Talk a little bit just to familiarize you with the cytochrome P450 enzyme system. Obviously, that becomes very important when we talk about toxicokinetics and pharmacokinetics, what xenobiotics are. Obviously, I have APA references in text references, elimination, etc. And then what I do is I focus even more, and this is one of the big changes that happens, is that in the undergraduate level, my bachelor degree, we talked a little bit about pharmacokinetics and just kind of left it at that. And now I'm actually having to focus in on the quantitative basis of xenobiotic diffusion. And whenever you see the word quantitative, you can almost guess, yep, it's going to involve some math. And obviously this is a science degree, and there's going to be some math that ensues. So we talk a little bit about diffusion, and obviously when you're talking about change, you can expect to come up against a little bit of calculus. Okay, differential equations are going to make their way in. And I think if you're going to work on any sort of master's degree where you're dealing with pharmacology, you're probably going to have to expect to run into some differential or some basic differential equations. I would say even if you've never taken calculus, you can go to YouTube and watch the Khan Academy calculus videos. I'd actually recommend that because it's really going to give you a heads up and help you get through these courses. And even if calculus isn't necessarily a requirement, it's not a requirement for what I'm doing, the fact that I can put these differential equations in and talk about these equations with some amount of efficacy really does help me excel and kind of move beyond just being a mediocre student. And another thing is I am up against the other students that I'm with are people that have degrees in chemistry and engineering, a couple of physicians as well. So that's those are the kind of people that I'm in class with, and so the expectation is that even though I'm a nurse, there is an expectation that I'm going to have to put out quality papers and projects. So calculus, at least a basic understanding of what it is really going to be pretty helpful for you guys if you're looking at any kind of degree in the sciences. So this is just a fundamental equation. This is actually a pharmacokinetic equation. It just talks about the rate of diffusion across the membrane. dq dt is just the rate, or d is just the derivative or differential. Q is diffusion with respect to time, equals this little equation here, dAk multiplied by C1 minus C2 divided by H, where d is a diffusion coefficient, and C1 minus C2 is a concentration. That really is a kind of a driving gradient or driving pressure for the diffusion of xenobiotics or medications. A refers to the surface area of the membrane. More surface area, a better chance of diffusion occurring. And then K is something known as the partition coefficient, and all that divided by H, which is the thickness of the membrane. So this is kind of one of those fundamental formulas you need to talk about, and I described that a little bit. I also describe concept. I kind of break that down into individual components and then talk about how you can inhibit or enhance the rate of diffusion across specifically intestinal membranes based on a basic quantitative analysis of those concepts. And then I talk about solubility and permeability, and what does it mean to be soluble, what does it mean to be permeable, and a real big thing that plays a big role in solubility and permeability is whether or not a substance is polar or a nonpolar. Nonpolar substances, typically substances that are very lipid-based, tend to penetrate membranes very effectively, but they're not necessarily capable of dissolving in water or an aqueous environment as effectively. So they may be able to penetrate membranes, but they may not be able to be distributed or to move around aqueous compartments as effectively as, say, a polar substance. And then polar substances may not be able to effectively penetrate membranes, but they're very good at dissolving in aqueous environments. And a lot of, when we talk about moving or absorbing medications, drugs, xenobiotics, what have you, a lot of it comes down to what form is that xenobiotic in. Is it a polar, is it a charged form, or is it a nonpolar or a non-charged form? And how can we make it charged and non-charged? And that actually plays a pretty big, important role in the absorption of medications. And clearly, pH changes are very important. In fact, I have a whole area where I talk about the role of pH, and this is where a good understanding of chemistry comes into play. I would say that this good understanding of general chemistry is going to be very helpful in my experiences. And unfortunately, the type of chemistry, or the area of chemistry that I talk about when we talk about acid-base, is an area of chemistry that a lot of people find very confusing. And specifically these sets of equations that I have in here, which are just fundamental, but they're often very confusing. So this is a concept known as the Ka, or the dissociation constant for a weak acid, which is really important because a lot of substances are weak acids. Now, this doesn't necessarily apply to a strong acid like hydrochloric or hydrofluoric acid, because they pretty much dissociate completely in an aqueous environment, so we don't really use Kas to talk about them. But certainly your weak acids, a lot of your xenobiotics are going to take on a weak acidic forms, such as I believe acetylsalicylic acid, something I talk about, is a weak acid, and we talk about your Ka, which is a way of figuring out how effectively it dissociates in an aqueous environment. Is your A negative, which is conjugate base multiplied by the acidic form, divided by excuse me, um, the concentration of just its basic form or its original form. And of course, anything in brackets, when we talk about something being in brackets in chemistry, that it typically is talking about moles per liter concentration. That's the Ka value. And then generally what we do when we get the Ka is we take the negative log base 10 of the Ka, and that gives us a bit more of a manageable number, the pKa value. A large pKa value means that acids are going to have smaller amounts of dissociation, vice versa for smaller values of pKa. And we talk about what pH means, the relationship between pH and pKa. And pH is really just the pKa minus or multiplied by the negative log of your substance divided by its conjugate base. I rearrange it, and this is where good understanding algebra comes into play. Just kind of rearrange this equation down here, where the log now, and I've just moved this negative over to the pH here, and so the log of HA divided by A, the conjugate base, equals the pK minus pH. And then I take the pH in the stomach and insert that, plug and chug some numbers, and I get a ratio of about 70, approximately 79. And that's when we talk about aspirin in the stomach. In the stomach, where I have a very low pH, and plug those numbers in, I'm going to have 79 parts of the protonated form versus 1 part of the conjugate base form. And what does that mean for absorption in the stomach? Well, it means that aspirin will be in a highly non-ionized form, which in theory means that it should be able to absorb in the stomach. But the surface area of the stomach, going back way up here, the surface area of the stomach is relatively small, so you don't actually have the absorption that you would predict based on pH and solubility. But when you get down into the small intestines, even though the pH is higher and the solubility is going to be much lower for aspirin, that's more than made up for by the massive increase in intestinal surface area, which really allows for absorption. So you can see it kind of gets complicated, and there's a lot of stuff going on, and unfortunately have to be able to talk about that stuff and have a pretty decent understanding of mathematics and general chemistry, and as we go along, obviously, an understanding of organic chemistry, biochemistry, and even when we start talking about D block elements and heavy metals in later classes, I assume that some inorganic chemistry is going to show up. So that puts someone like me, who I have a science degree by definition, but it's perhaps not as hard, quote unquote, hard a science degree as a chemistry or physics degree. So when you start looking at these science type graduate courses, you got to keep that in mind if you're like me, where you may not have as robust of a science education as some of the other people. What am I going to have to touch up on, read up on, and work on to be successful at these graduate level classes? So anyway, that was just kind of some babbling, and hopefully that kind of gave you an idea if you're looking at graduate school, and just kind of the difference of the type of thought process that goes into graduate versus undergraduate classes, and the more of the detail, and some of the additional quantitative stuff that you may run into. And again, this is probably not going to apply to every graduate degree, because there are lots of different types of graduate degrees, and maybe it's a literature or fine arts type degree, and there may be other things. So I can really only relay from my limited experiences at this point, but hopefully somebody found that helpful and kind of interesting. All right, guys, as always, thanks for hanging.